Welcome students. This is the second lecture video for design of concrete structures. So before starting with the syllabus, I would like to revise few concepts which you have already learned in your previous semester, which is a prerequisite to start with RCC structure design. So here we will be covering what is concrete and what is steel. To start with, you all know what is this material, that is concrete. It's a building material made from a mixture of broken stone or gravel, sand, cement and water, which can be spread or poured into a mold and forms, and it hardens and it takes the shape of the mold. It has very high strength. So basically it is made of cement which acts as a binder. It is made of coarse aggregate which gives strength to the concrete. We pour fine aggregates into it, which fills the voids between the coarse aggregate and cement, and we add water for hydration process of cement so that the concrete gains strength. Concrete has very good properties. So to list few, first is mechanical strength, in particular compressive strength. Second is durability, porosity and density, fire resistance, thermal and acoustic insulation properties and impact resistance. As I already mentioned, concrete has relatively high compressive strength but significantly very low tensile strength. There are different grades of concrete. So you have already learned this in concrete technology. So the grades are given as M10, M20, M30, M35, M40 and so on, in which M stands for the mix and the number after that stands for the compressive strength in Newton per mm square after 28 days. And the strength is calculated for a cube of the size 150 by 150 by 150 mm. So the grade of the concrete is decided depending on the type of exposure of the structure. So there are three conditions for exposure. One is severe, moderate and low. So the exposure, depending on the exposure conditions, you need to select the mix for the concrete to be used for construction. This is mentioned in IS 456. The next material that is used for construction is steel, and which is very important. Steel is an alloy of iron with typically a few percentage of carbon to improve its strength and fracture resistance. It's called as rebar, so it's a short form of reinforcing bar and known when massed up. The second most important material that is used in RCC structure is steel. Steel is an alloy of iron with typically a few percentage of carbon to improve its strength and fracture resistance. So it's called as rebar. It's a short form of reinforcing bar. So when this is reinforced with concrete, it gives or it resists the tension that is experienced by any component in the structure. You will be learning this when we start covering RCC structures, that is reinforced cement concrete structures. This steel is available in as different types. First is mild steel, that is mild steel plain bars. As you can see in the picture, these are steel bars but which are plain, which has a very plain surface, and these are available in the market in different sizes depending on the diameter of the bar, starting from 6 mm to 50 mm. Usually for structural building, mild steel is not recommended as it does not form a very good bond between the concrete and steel. So there can be slippage or there can be a less of strength at extreme conditions. Mild steel have a yield strength of 250 Newton per mm square, and hence it is known as Fe 250. So Fe is a notation of steel and 250 is its yield strength in Newton per mm square. The next type of the steel is deformed steel bars. These deformed steel bars are again available as two forms. One is hot rolled high yield strength bars and second cold worked steel high strength bars. Hot rolled and cold worked are divided depending on the process of making these bars. So we'll see into detail what is this hot rolled and cold worked steel high strength bars. To start with, hot rolled, from the name itself you can make out that these bars are uh, made or processed at a very high temperature. That is the reason it's called as hot rolled. These rebar surface are often deformed with ribs or lugs. So in the picture here you can see there are these ribs on the bar. As compared to mild steel, the surface is very plain here, and here in deformed bars it has lugs here or ribs here, which basically increases the surface area of the bar and it gives very good bond with the concrete. So these bars are high yield strength bars, also known as HYSD bars, basically available in two grades, Fe415 and Fe500 in the market. Again here Fe stands for the notation, and 415 and 500 is the yield strength of the steel respectively in Newton per mm square. Now recently there is another type of steel that is available, or basically another grade of steel that is available in the market, that is Fe500D. I want you all to know, or I want you all to find out what is this Fe500D, what that D stands for, or what is a property of the steel that is mentioned in that D. And also, if you have seen advertisements on the TV, they advertise this steel as TMT bars. These are TMT bars. So I also want you all to find out what is this TMT stands for, or what is that TMT bars. So it's a small assignment for you all. I want you all to know these two terms, Fe500D and TMT bars. Okay. So to go ahead, next is cold work steel high strength bars. Again, as the name suggests, these bars are processed at room temperature, or it undergoes cold working. They have less ductility as compared to hot rolled bars, and they are also known as CTD bars, which stands for cold twisted deformed bars. These are available in two sections in the market, that is TOR 40 and TOR 50. Usually, hot rolled bars are used as it has very high ductility and very high strength. Next is pre-stressing steel bars. There is a concept of pre-stressing which is used or highly used in these recent years in construction. We will be covering this concept of pre-stressing in Unit 4 in detail. So basically there is a different type of steel reinforcement that is used in the process of pre-stressing. So if you see the picture, you will be able to see one particular rod is made of different wires, maybe 3 wires, or here there are 5 wires, or you can also make it with 7 wires. So one particular rod will be a combination of 3 or 2 or 7 wire strands. So the wires used here are cold work and have very high tensile strength. So, as I said, I want you all to know some terms which are connected to concrete and steel. The first one is compressive strength. Read what is compressive strength. Understand the concept of compressive strength of concrete, because you will be needing this for entire design subject. Again, tensile strength of steel, yield strength of steel, and TMT bars and Fe500D. So just Google and find out what these terms exactly mean. So for detailed notes for this presentation, kindly visit my website www.shrutizamre@wordpress.com. You will get a PDF. You can download it and read the notes and understand the concept, or basically the two materials, that is concrete and steel, which will be used for construction of RCC structures, and we will be dealing with these materials for the design of concrete structure concept understanding. In the next video, we will be going into stress and strain of these two subjects, so these two materials, that is concrete and steel. Thank you.